Hello and welcome to lesson 2.2. We're going to cover displacement and velocity. Now for most of the year, displacement will be very similar to distance and velocity will be very similar to speed. In fact, we'll use those two pairs of terms interchangeably most of the time, but at least at the beginning here, we want to know the difference between each of these values. So we'll start by defining displacement and velocity. We'll introduce an equation for velocity, and we'll do some examples for each of these. Starting with displacement. Alright, so displacement. Like I said, it's kind of like distance, with a twist. Displacement I have defined here as a vector that points from an initial position to a final position. A vector that points from an initial position to a final position. So initial means beginning, final means end, obviously, so we need to pick a start point and an end point for this object if we're going to find displacement. Also, there's this word vector. Vector basically just means arrow at this point in the class, so it's just a vector that points from the start to the end. The more important thing about the word vector is that it includes direction. So since displacement is a vector, we need to always include a direction along with our displacement. So let's put that as a little note. Must include direction. So direction can be up, down, left, right. It can be north, south, east, west. But in mathematical terms, we could also have directions as a plus sign or a minus sign. That pretty much covers all of them. So north, south, east, west, up, down, left, right, plus and minus. So plus would mean right. I shouldn't use my hands, I'm getting mirrored here. Plus means right, minus means left. Plus can also mean up, and minus would then mean down. We'll get used to this as we go on, but basically, yeah, those are the basics. So let's do an example calculating displacement. Alright, here we have it. A student goes 600 meters east, then 200 meters west. Calculate distance and displacement covered by the student. Okay. Student moves 600 meters east, then 200 meters west, calculate A, distance, and B, displacement. Now remember, distance is the total amount of ground covered by something. So the student goes 600 east, 200 west, that's a total of 800. So right away, we can kind of get our distance written down. So yeah, I'm gonna do a drawing real quick. So east is, here's a little compass, in case you weren't sure. Never eat sour watermelons, goes clockwise. Never eat sour watermelons. So we've got, the person's going to go 600 meters east and 200 meters west. And I'll write down my distance. I know that one, I just add them up. Show your work, even though you're just adding two simple numbers. Distance equals 600 plus 200, that's going to be 800 meters. Bam, got half my problem done. Now displacement, we have to use the definition we just wrote down. Very important. It points from an initial position to a final position. We need to establish both of those. Here's my initial position. I'm going to use a special notation for it. It'll be P0 rather. The 0 means initial, it means starting, and P means position. And PF thus means final position. Now they can't be swapped because look at the way it's written. First they go 600 meters, first they start here and go this way, then they turn around and they go that way. So there's our initial, there's our final. Displacement, it's a vector that points from initial position to final, so it has to point from the initial to the final. The reason we have to point it from initial to final is so that we get the right direction. The size of this has got to be 400 because it's what's left over. It goes 600 that way, then they take off 200, so it'll be 400. I guess technically I should write that in my, I should show my work of what I'm thinking. So displacement is 600 minus 200. So it looks like they are 400 meters from where they started. But I need a direction. There are a couple things I can do. I can say, I could put a plus sign in front of the 400. That would be direction. But what I'm going to do is use the context that they gave us. They told us east and west, so I'm going to use east. So 400 meters east. Displacement, it's a straight line that points from where we started to where we ended, but it's also, displacement can also be thought of as how far we are from where we started. So we're 400 meters toward the east from where we started. So there's our displacement. On to velocity. All right, velocity. Okay. Velocity and displacement are related in the same way that speed and distance are related, where we just divide it by time. So velocity is just simply displacement over time. It is also a vector. Velocity is also a vector, so once again, it must include direction in our answer. Alright, here's the equation. It's going to be kind of a new looking thing. It looks pretty similar to the speed equation. We'll have to add a little bit of flair to it. Okay, we're not done writing it yet. So if I have V equals triangle P, it's a Greek letter called delta. V equals delta P over T. So a little thing I'm going to add that very often we'll leave out, just kind of cool symbol, it looks like a harpoon. It's the vector symbol. It's just a reminder to physicists that V must include direction. And we won't always write the equation like this. You can kind of drop the harpoons. It's just something that I want you to know why it's there. So we'll see these all year, these little harpoons. It's just a little reminder for you that the answer must have direction. Let's just see another example. Okay. So here's pulled this data from offline. We have John Ross from the Cincinnati Bengals. I looked up that his 40 time is 4.22, world record, 4.22 seconds for his 40-yard dash. Let's say he runs west, and we're going to calculate his velocity. Calculate John's velocity if he goes 40 yards west in a time of 4.22 seconds. Something I forgot, something I left out is our units. So I'm going to go back to this equation here. But it'll be reminiscent of the old equation. Velocity, it's measured in meters per second. I bet you could have guessed that. Displacement, that's what delta P is. It's measured in meters. And T is time. It's measured in seconds. Anyway, the reason I thought of that is because, look, they have it in yards. I'm going to look up how many yards, how many meters in a yard. And we'll use that. I'll do how many yards in a meter. Alright, we'll convert that. So it looks like there's 1.09 yards is 1 meter. Alright, back to the problem. So we're trying to get John's velocity. It's going 40 yards west. That's going to be our displacement, but let's convert it first. 40 yards. We'll do 1.09 yard on bottom, 1 meter on top. So we'll divide by 1.09. So that's 36.7 meters. And just as a little reminder for myself, I'm going to write west. So 40 yards west is the same as 36.7 meters west. 4.22 is our time. We'll go ahead and try to calculate our velocity, and we'll do so here. So the reason I'm showing you this problem, is this west right here. Hope you recall, so we have east and we have west. West is negative because it's left on our page. If we look at our compass up here, east is to the right, so that's positive. West is to the left, so that's negative. South would be negative and north would be positive. So maybe draw that diagram if you're going to have trouble remembering that. But the important thing is that when you plug the numbers into the equation, you make them negative if they're pointing south or west. So negative 36.7 over 4.22. That'll get us our velocity. 36.7 over 4.22. Looks like his velocity is 8.70, negative 8.70 meters per second. Some other ways you could write that answer would be 8.70 meters per second west. So you either need the negative or the west. Shouldn't do both because then you kind of have like a double negative there. Long story short, velocity has to have a direction, just like displacement does. Alright, we'll take one more example comparing speed and velocity, and actually one short one after that. So remember, speed is distance over time, whereas velocity is displacement over time. So speed is never negative. Velocity is negative if something's moving south or west. So here we go. Let's calculate both. There we go. Over the course of 10 minutes, A student runs 800 meters north, then 150 meters south. Over the course of 10 minutes, a student runs 800 meters north, then 150 meters south. Calculate the speed of the student and the velocity of the student. Calculate A, the speed, and B, the velocity of the student, if you wish. Once again, over the course of 10 minutes, the student goes 800 meters north, then 150 meters south. Calculate speed and velocity. So I'm going to write three things here. I'm going to do a diagram, and I'm going to do both the equations. So here we go. 800 meters north. From there, they turn around and they go 200 meters south. Very important that your arrows are somewhat to scale, so my 200 meter arrow should be shorter than my 800 meter arrow because they don't make it all the way back to the start point. Speed will be found with this equation, and velocity with this equation. Alright, distance is pretty easy. Distance is just the whole distance that they cover, all the ground. So distance will be 800 plus 200, that'll be 1,000. I can also write it straight into the equation. So let's keep them off to the side here. Make like a little inventory of my values. So D is going to be, oh man, D is actually going to be 950. I made a mistake with my drawing. That should be 150 meters. How embarrassing. Okay, 150 meters actually. Time is 10 minutes, but of course we want that in seconds. To convert it, we will multiply by 60. 60 seconds in a minute, so we multiply by 60. So that's 600. Time is 600 seconds. And displacement, remember, take a look back at your definition if you're not sure. Displacement is a vector that points from initial position to the final position. So it looks like it points north. I'll write my displacement as well. So it would be, you got to subtract those two. 800 minus 150. So it's 650 north. Or plus 650. So something going north is positive, so we'll leave it as 650. Okay. Time to do our calculations. Speed is going to be the total distance, that's 950 over 600. So that's 1.58 meters per second. And velocity is going to be positive 650 over 600. So that's 1.08. This answer right here is technically incorrect because velocity is supposed to have a direction. So to make my answer complete, I can either write north, or I prefer the plus sign in front. It's very different from math in that a plus sign actually has meaning in physics. A plus sign denotes our direction that we're moving. So 1.08 and plus 1.8 are two very different things. That's about it on that one. So there's all the math. I'm going to close here with just a quick differentiation question. Identify each of the following as a distance, a displacement, a speed, or a velocity. Identify each of the following as a distance, a displacement, a speed, or a velocity. I'm going to write them all down. Maybe pause the video and try them on your own, and I'll tell you the answers right after. Okay, here we go. One at a time. Starting with A. It's in meters per second, so it has to be either velocity or speed. But I know that it is speed, because velocity has to have a direction. B. It's meters, so it's got to be either distance or displacement, and I know that it is displacement because negative is some sort of direction. We don't know exactly what. This negative could mean down or left or west or south. We're not really sure until we get some context for the problem. But either way, negative is direction when it comes to something in meters. 18 meters per second north, well, that's velocity. Because it's in meters per second and it has a direction. Same thing with D. Velocity. Now once again, the plus sign is weird for us because most of us have just taken algebra. The plus means up or east or right or north. So the plus is a direction, and meters per second is the unit for speed or velocity. Meters, it's got to be distance or displacement. This one is distance because there is no direction. And finally, 12 meters up is displacement because up is a direction. So that's our show. If you have questions, let me know, and I will talk to you soon.